Hi guys, welcome to problem 15. Today we're going to do this in two parts. We're going to do it in the first part learning about capacitors in a circuit, and then learning about inductors in a circuit. So for capacitors, if we have a circuit like this, we could simplify the circuit to find the equivalent capacitance by looking at the series and parallel components of capacitors. So in series, capacitors they behave like parallel resistors. So for example, if we have two capacitors in series, it's equal to 1 over C1 plus 1 over C2 plus all the way to 1 over Cn inversed. Capacitors in parallel, they act like resistors in series. So that's C1 plus C2 plus Cn. So if we look at this circuit here, we're able to find an equivalent capacitance. So let's look at the 2 microfarads and the 4 microfarads. So we can see that these are in parallel. So if these are in parallel, we use this formula and we just add them together. So Cp is equal to 2 plus 4, that gives us 6, and then we're able to redraw the circuit. So if we're able to redraw the circuit, it looks like this. We have the 3, we have 12, these two become 6, which we just calculated, and then we have the 3 at the bottom, and the 2 across. So this circuit here, we're able to simplify again. We can see that these two, the 6 and the 3 microfarads, these are in series. So in order to find these two capacitor combinations, what we do is we do CS is 1 over 6 plus 1 over 3 inversed, and that gives us 2 microfarads. Again, we're able to redraw the circuit, and once we redraw the circuit, it becomes the circuit here where we have 3 to 12. These become 2, which we just calculated, and then we have 2 across. Now let's look up over here. So we can see that the 2 and the 2, these are in parallel. So if we use the parallel equation, what we do is Cp is equal to 2 plus 2, that gives us 4, and we're able to redraw the circuit again, where we have 3, 12, and 4. Okay, so as we can see here, these are all in series. So since they're all in series, we use the series equation, end up with CS is equal to 1 over 3 plus 1 over 4 plus 1 over 12 inversed, and again we're able to redraw the circuit, and that becomes 1.5. Well, this is just equal to CEQ, so CEQ equals 1.5 microfarads. So just to recap, that when looking at a combination of capacitors, capacitors in series act like resistors in parallel, and capacitors in parallel act like resistors in series. Okay, so now we're going to look at inductors. Now we're looking at a full inductor circuit, and like what we did with the capacitance network, we're going to find the equivalent inductance of a circuit like this. So whenever we see inductances in, inductors in series, we add them like this, almost like resistances in series, and inductors in parallel, we add them in this formula like resistances in parallel. So it's kind of like the opposite way of capacitances. So looking at this inductive network, we're able to find the equivalent inductance. To do that, let's look at these two inductances. These two inductors are in parallel, so we can use the parallel formula. LP is equal to 1 over 6 plus 1 over 6 inverse. That gives us 3. So we can redraw the circuit. If we redraw it, it looks something like this, where we have the 3 millihenries that we just calculated. We have the 6 right across, because this is connected to this node here. We have the 6 here, 6 here, and the 6 there. So again, if we look at these two right here, these are actually in parallel, because these nodes are the same and this node is the same. So again, we could use the parallel inductance formula, and we get 1 over 3 plus 1 over 6 inversed. That comes up to 2. So we're able to redraw the circuit again. So we end up with something that looks like this, where we have 6 millihenries. We have the 6 millihenries that we just moved up, this one right here, up to here, because these two ended up being calculated to 2. So we could put 2 over here and 6 here. Well, if we look at this, we could see that 2 is in series with 6. So we could use the series formula, which is 2 plus 6, that gives us 8. So you're able to redraw the circuit again. To redraw the circuit, we have 6, 6, and the 8 millihenry that we just calculated. You can see 6 is in parallel with 8, so we use the parallel formula, which is 1 over 6 plus 1 over 8 inverse. That gives us 3.43 millihenries. So again, we could redraw the circuit, 3.43, and then the 6 millihenries there. Now these two are in series, so we can use the series formula, which is just the sum. That gives us 9.43 millihenries, which we could redraw. 9.43. This is LEQ, so LEQ, the equivalent inductance, comes up to 9.43 millihenries. So just to sum up, inductors in series are the same as, or add up in a way like resistances in series, and inductors in parallel add up in a way like resistors in parallel. So the opposite of how capacitances are calculated to find the overall equivalent capacitance. All right, thank you.